Hey dudes, binomial expansion crash course. Here we go. So if you look at a binomial expansion and you multiplied 3x plus 1 by itself 4 times, it would look like this. You'd, well here it is, this piece. It would look like this, a to the fourth, da 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 da, be this chunk. And you can see this pattern happening. That if you simplified all of this, it would turn into this mess. And you'd find this piece that these components in the front come from Pascal's triangle, this binomial expansion. The coefficients are from that piece. And then you can see that this A term starts here with the highest power on it, n, and slowly, I should do this in blue, what am I doing? It's okay. And then slowly decreases. This is n minus 1, this is n minus 2, this is n minus 3, and this is n minus n, right? And slowly decreases until 0. And conversely, this B component starts at 0 and works its way up to n. So you can use that to find the coefficient. When they say the coefficient, they mean the number in front of a certain term if you're sneaky. And we're sneaky, so this is how to do it. I'll show you one here that's from the text, and then I'll show you one that's my own. So we want to expand this. It's the gnarliest one I could find. Find the coefficient in front of the x to the sixth. Well, I know that this is the A term and this is the B term, so let's pop those in there. And I know that there's going to be 12, n is going to be 12. It's going to start, there's going to be 13 terms, but like this, the n goes from 4 down to 0, and from 0 up to 4, up to that maximum exponent. So I know that n is 12. All right. So this mess is going to, like every term is going to look like this. This component, if you've forgotten, is 12 choose R. Right? It's from our probability sense, and you can do that on your calculator. If you've forgotten how to do that, it's math. Everything good in life is in math. And then over to probability. And then C, and choose R, right? And then you put in 12, choose whatever we find. We'll get there in a second. This is a short way of writing that. This piece means I have these x squared values, and for each term it starts at 12, and for each term it decreases by 1, right? So that's this x squared, 12 minus r. I'm going to put this in brackets just so we can kind of keep it separate. And then this piece is this component, and it starts at 0 and comes up to the full n value, increasing by 1 each time. So this and r, like that. Okay, so this describes each of the terms that we have, and so we can use that to figure out the pieces we want. You can clean this up a little bit. If you multiply this x squared into here, or the 2 into the 12 and the r, and also if this is r4 to the r and x to the r, but in the denominator. So with your mathematical prowess, you can clean this green piece up into this just by distributing the 12. You're multiplying the exponents, so because it's a power on a power, so this just distributes in there, and then this is the same. The r distributes into the numerator and denominator, and with that then you can take these r values and separate this component just becomes 4 to the r times 1 over x to the r, also known as 4 to the r times x to the negative r. That's being multiplied right next to this. So just multiply your x's, because this is x to the 24 minus 2r. So you can combine the exponents by addition, and that's where they get this part. right? So x to the 4r is still sitting here. That's this piece. And this piece is a combination of these two. I think that's the hardest part, is just putting the exponents together. All right, so this is an expression for each term. We have a number out in front. It's going to be multiplied by whatever this 4 to the r is based on our term number. And this is a description of the x component. In A, it says I want to know the coefficient in front of x to the 6th. So we can say that that exponent, the 24 minus 3r, we can say that this piece should be equal to 6. So we can set just this equal to 6, and that's what they did here, I believe. Yeah. All right. So they want this exponent to be equal to 6. So 24 minus 3r has to be equal to 6. And then they solve for r, which tells you which term number you want. All right, so we solved and found r is 6, and then what we can do is plug it back into all the stuff that isn't x. Right? We know that this piece, when we plug it in, is going to be, when we plug r6 in for r, this term is going to be 6 also. It's not always like that. Sometimes it's a different number. Often it's a different number. But we're going to plug 6 also into there and figure out what this whole value should be. So it should look like this. We plug 12, choose 6, 4 to the 6, and we know this one's going to be x to the 6th because we've done this calculation previously. So you grab your calculator and you say 12, choose 6, like that. All right. I got 924 and 4 to the 7th, say times 4 to the 6th, and I got that number, right? Yeah, ching, sweet. Fine. Find the constant term. The constant term has x to the 0. Right, and some number before it, 725, making this part up. But this part, x to the 0, is 1, so it's 1 times whatever that number is in front. It has no more variables, which means it's constant. All right, so we play the same game with this same equation. Right, let's get rid of all of this, just so it's not in our face. And instead of setting the variable on x to 6, we're going to set it equal to 0. So we want all of this to be equal to 0. That happens when r is 8, term number 8. When we play the same game, plug 8 into that r and that r. Like that. We know x to the 0 is just going to be 1, and that's what we're counting on. So 12, choose 8 in your calculator. It's 12c8 times 4 to the 8th. And you should get that number. Yay. All right. If you think you got it, try it here. I'll show you the answer and try to get it myself in a second. If you're still not sure, let's try it. All right, so there's the answer. So we want to find the coefficient of x to the 10th in this expansion. I know this is going to look like 10 choose r, or you could write it in that vertical style, but I like this better because it helps me remember. I know that I've got 3's that are starting at 10 and decreasing every r, and I know I've got 2x squareds that are starting at 0 and increasing by r each time. All right, so what we need to do is sort of isolate the x's. There's no x's in here, so it's a lot easier than the last one. So this piece should turn into 2 to the r, x to the 2r, and then we still have all this stuff in front. Let's see how savvy we can be. Great. So I know this this happens, our exponent is 10 when this is equal to 10. So when is 2r equal to 10? Well, when r is 5. And this is a good sign, right? So therefore I want r to be 5. So then we calculate what happens to all of, run out of colors, all of this when r is 5. So this becomes 10 choose 5 times 3 to the 10 minus 5 times 2 to the r is 5, so 5. And we run those through our calculator. Kiss that beauty. You should, so that's where this comes from. You should get 252 and that, which turns into that. Fun, moving on. All of this is useful for probability. Like in itself, not that useful, but it does work well in discussing probabilities. And so the clumping this together, the binomial distribution, probability distribution function, looks like this. And this is when you might use it. So 72% of all ISL seniors are in favor of removing the English requirement to graduate. A random sample of 5 members are taken, and we want to know what's the probability that 3 out of those 5 are in favor to the change. Right? So what's the probability that out of these 5 we get a vote, a majority vote, that we ditch the English classes and spend more time on math? So well, let's see. I know a couple of things that overall we've got 72% are in favor. So this is the percentage we're talking about, right? Like we can talk about, if you remember probability, we have to multiply the probability that something happens by the number of times that might occur, and also the probability that it doesn't happen times the number of times that might occur. Right? That's where this piece comes from. And if you want to look back in the notes about where this function how this comes about, you're welcome to, but this is the crash course, so we're just going to use this probability distribution function. So we can say this, our n should be 5 because we have only 5 people in the sample, and so that's where this comes from. We also know our probability is 72%, so this piece is this, 72% is 0.72, so therefore this piece, I'm running out of colors, this piece should be 1 minus 0.72. This is the probability that it will happen, this is the probability that it won't happen. So that's where this 0.28 comes from. That's this. So this is the probability that it will happen, and this is the R value that we're looking for. That's this. And this is the probability that it won't happen, right? So the 5 minus 3. Yeah. All right, and this is our coefficient in front, 5 choose 3. And if you run those through your calculator, you should get that. And so that means it's about a 29, maybe 30% chance that this will happen. All right, great. So coupled along with this, there are also some formulae that they like to throw at you once in a while. One is about the mean, the other is about standard deviation and variance. They're coupled together. Mean is really just the number of times that something happens times the probability. So that's the n times p. Standard deviation is this big ugly derivation to get here. Good news is they give you all of it. They say the mean really is like the expected value is the number times the probability. And the variance is the number times the probability times 1 minus the probability. And therefore, to get standard deviation, the variance is standard deviation squared. So you can go back and forth between those. So this is the part that they don't, they only give you variance. So they only give you this. And you kind of have to know that to find the standard deviation, you take the square root of the variance. So standard deviation is square root of the variance. All right, so if you took the square root of this side, you'd get just the standard deviation. So that piece isn't explicit in your notes. But generally they'll just ask you to use this. They'll say, hey, the standard deviation is 5 and the probability that something happened is 0.7. Find the number that occur, right? And you just use one of these to figure those out, and then maybe later use it to find the mean. They're not that, they don't show up that often, and generally they're just following the formula from one to the other. All right. So here's an example of that. They said, all right, 5% of iPhone batteries are defective and will explode in your pocket. A random sample of 80 batteries is taken with replacement. Find the mean and the standard deviation of the defective batteries. Okay, well, it's binomial sampling. So we can say the number that we're sampling is 80, and the probability that it's defective is 5%, right? Another way to say 5% is 1 in 20, 1 out of 20. Fine. We want to find the standard mean and the standard deviation. I think we're going to have to do this first because they gave us, if you look at the equations, they gave us the n and p. So they gave us this, oh, and that. Great. So you multiply them to find the mean, the mu. Right, so that's this piece. Okay, and then to find the standard deviation, you throw them into the standard deviation equations. I guess we'd throw them into variance and then take the square root to find standard deviation. And that's the jump that they're asking you to make. So you put n and p into there and there and there. You get the variance, and you just have to know that take the square root and you get the standard deviation. Not sure why they stressed that, but there you go. All right, more to come. Bye.